Here you see on the screen the essential parts of any C program. And in this today's video, we will learn to reverse the data of a linked list. And since we use here the linked list, for that we use the malloc function, and for that we have to use an additional header file stdlib.h. Now a linked list store data. For that I have to suppose the data which I will store in the linked list is of integer type. For that I have to use this keyword int, and I have to take a variable element under which the data will be stored, and later this value will be stored in the node. And thereafter I take one more variable count with initial value 0. This variable count will be updated, and at the end we will have this count equal to the size of the linked list. And one more thing, since I have to sort the elements, or you may say the data of the linked list, so I have to use the sorting technique. And here in this video I will use the bubble sort algorithm, and for that I have to take two more variables I and j, and these two variables I will use for the sorting part. In the bubble sort we take two for loops, and for the first, or you may say for the second, I will take I, and for the other for loop I will take j. So I have taken here two more variables I and j. And now, since we have to deal with linked list, so I have to declare a node. This is user defined data type, and here we use singly linked list. And for that, in linked list, it is made up of nodes, similar nodes, and in this a node contains two parts. First is the data part, and second is the self referencing pointer. And here for that struct node, and here that pointer is star next. So there are two parts written on the screen. Now we take some variables, and here I take struct node. Here I take first. This variable always point to the first node, so initially it is assigned null because I have not added any node to the linked list. So initially this pointer first is assigned null, and we take two more, two three sorry three, and sometimes it may not come in your mind, but when you proceed, then you need more variables, and on that situation you can add here. So I take for the time being three more variables here: star move, here star temp. This star temp is for the newly created node, and one more star front, and this will be used. This star front will be used when we type the sorting part. Okay, now in a linked list we can attach, we can have many number of data, and for that it is better to use an infinite loop. Here you know one, inside the parenthesis you see one, this means that this is always true, and so this while loop will run forever if you don't control. But a user may not be with this program forever. For that, this must end, and for that, first this infinite loop must be controlled. To control this, we use a scanf function inside this, and for that, first we show a message to the user. This message, enter the data, enter the data, and when the user sees this message, he will certainly enter a data, and you have to scan that data. So here a scanner function is helpful for two purposes: first, to scan the data inserted by the user, and the second, to control this infinite loop. And here %d, and thereafter here ampersand, to store the data inserted by the user under the variable name element, and at an address for that ampersand element. Okay, so we got the data, and suppose, since this is a infinite while loop, so obviously we want to terminate this loop at a at any moment. For that we take a condition. Suppose we deal with positive numbers only. In that case, it is better to take any negative number. And I take that negative number to be -1. So whenever I insert, or a user inserts a -1, then the linked list will be terminated. And accordingly here, if element equals to -1, then we don't need any more data into the linked list, and for that means we want to come out of this loop. For that we use this keyword break. Now if that is not the case, we want to remain with the linked list, so for that we have to create a node first, and all nodes will be created under this pointer temp. And who will create? The malloc function will create. And what is the type? Type is, you see here is the temp, here is the temp, and its type is star and a struct node. And if you read together, then this will be a struct node star. So accordingly here we have to type struct node star. And who will create? Obviously the malloc function. So malloc here, And what is the size of the node? And here you see the node, and here is the node, struct node. So accordingly I have to type here size of struct node. Size of a struct node, here will be a space and here will be semicolon to terminate. Now once you have the node, then you know a node has two parts, so you have to assign these two parts. And here I assign the data part. This is for the data part, and inside this we assign the element, that is the value in the under the variable element, and there is second part as well, and in that we accordingly take temp arrow next equals to null. So the assignment is complete. Assigning the values to the two parts of the node is complete. Now there will be a case. What is the case? You know, in a linked list, the elements, there will be different nodes, there will be many nodes, but the first node is unique. The first node is peculiar in a sense. In what sense? First node is peculiar because when you create the first node, then you need not attach this to anyone. You know, if second node is created, then second node will be attached to the first, but to whom you will attach the first one. So for the first node deal with you have to deal with this first node separately, and for that we I accordingly here have taken the keyword if first equals to null, and you know initially obviously first is null, so this part belongs to the first node, and in this case we assign this temp to the first, and also move is given the same temp, and since first node is created, so our count should be increased because initial value of count is 0. Since we have the first node, so it should be 1, for that count plus plus. And one more thing, when you have the first node, so in I already explained that there is no need to attach this node, so we directly go to the initial point of the while loop for the next run. For that I used here the keyword continue, and when we go for the second run, second node will be created, and in that case we have to write more C statements because the second node created should be attached with the first one, and for that I have to type additional C statements, and I type here now. Sorry, here will be move. Move is the first node now, and the link part of move should attach the second node, that is temp, and after attachment this move should point to the second node, and for that I typed here move equals to temp. Okay, now our while loop is complete, and we can add many number of data one by one. Uh, each run of this while loop will create a new node. If this is the first node, then it will remain as usual. If it is subsequent nodes, then that node will be attached with the last node in the linked list. And now I here use a while loop. First I type a program to create the linked list and to display the elements in the linked list. Thereafter I will go for the sorting part. And here, before going to that part, move is again made to point the first. And now here the condition is written move not equals to null. Okay, and now here, you know, to display the elements we use the printf function, and here %d backslash t to keep the elements at a tab distance, and here data in the move, for that move arrow data, and by this we can see the first data in the linked list, but we have to see the all data, so move should be moved. And for that, here I have to type an additional CS statement, and that is move equals to move arrow next. So far the program written, the part of the program written is that with this we can create a linked list and display on the screen. So let us see it's working or not. Okay, it says enter the data. I take 12, 4, thereafter 56, thereafter 34. Now I want to terminate. So to terminate, I have to take -1, and okay, it's working. You see here 12. So accordingly, you see here 12, thereafter 4, 56, 34. So far our program is working well, and now we go. I go to type the part responsible for the sorting, and for that part I have to add more CS statements, and here I add first, in bubble sort, swapping of adjacent data is done. So first I type for the swapping of adjacent data, and for that I take, and here I initialize the value of I with 1, the value of j with 1, and one more thing, here I have taken here count plus plus, and this is for the first node, and second node, third node should also be counted, and for that here I have to take the same count plus plus. Okay, now I here take I, or you may take here j equals to 1. Initial value of j is 1. Since I have taken here j equals to 1, so there is no need to write type here j equals to 1. I thought to use while loop, so I initialized there, but here I use uh, for loop, and here I initialized j equals to 1. J is less than count. Count is the variable which at the end gives the size of the linked list, and here j plus plus. Okay, you know, when you swapping, you when you perform swapping, then two nodes are taken at a time. So when you take a linked list of size 5, then there will be 4 swapping, one less. So accordingly I have taken the condition here. Now you see at the in the beginning that I had taken here one more variable pointer front, and that will be used here, and here this for loop starts, and here we take front equals to next of move, and by doing so front and move are adjacent nodes. And now there will be a condition, since we have to sort, so the condition will be if the data inside move is greater than the data inside front. If this is the case, then we do swap, and for that I have to declare one more integer variable, and suppose I take that variable to be integer. So here first I store one of these two data under integer variable. So here I take, suppose, the data inside move, and thereafter I store the data inside front into this data inside move, and accordingly I am typing, actually I am copying and pasting. And here at the end we store the data under the variable inter into front, the data inside front, and these three statements complete the swapping. Okay, so by this you are able to swap the first pair, that is the first data and the second data. But you have to take all the pairs. For that, here move should be moved. Its name is taken accordingly because I have to move this. So to move the variable move, I have to type this thing. Now if I do in such a way, then our uh, our one element, the largest element, will be at the end. And let us check whether it is happening or not. This is the way the programmers write the program. They don't write all of a sudden. They work in various parts, in various steps to check that they are going in the right direction or not. So I check this one. And one more thing here, this is the display part. This while loop is for the display. And in the in this while loop, you or you may say I have used this move. Here move means the first node, because if you go to display, then obviously you have to display the first element first. So you have to start from the first node. So this move should point to the first node. So I again type this C statement again, and now let us see our swapping of adjacent element is working well or not. So I take here data 4 5. Now I want to terminate, so I take -1, and you see swapping is complete. And I have used one for loop, and you see that here there are three elements: 1, 2, 3. When I used one for loop, then our largest element, you see 12 among these three elements, 12 is the largest, and that has gone to the end. You see that this is sorted, but no, if you take some other example, if you take more data, 10, 12, then you will notice that this program is not going to give you the sorted linked list. I show you, taking one more example. Here I run the same program, and here I take the data, and now I terminate, so -1. And now you see these elements are not sorted. you know 0 0 is smaller than 9. So if it were a sorted linked list, then 0 should be 0 were at the first place, but that is not the case here. So what should we do? I For that I have to use one more for loop, and and the same principle is used in the bubble sort. Bubble sort is a sorting technique, and I have already uploaded a video on that technique. You can see that video first, and thereafter you come here. So now I type the next for loop, that is one more, that is one more for loop so that we have complete sorted linked list. So here I type for loop, the outer for loop, you may say the outer for loop here, and here will be I already have taken j, I equals to 1, and thereafter I should be kept less than count, and I should be increased by 1 after each run. And here this entire thing I show you, this entire thing should be kept under a braces, under a pair of curly brackets. So I place here the curly bracket. Here is the opening curly bracket, and here below I place the closing one. Now this program will give us the complete sorted linked list. Let me check once again. Okay, and one we may refine this program as well. How can we refine? Okay, on that part I will go later. First, let us check whether we are getting the complete sorted linked list or not. Here we go. 12, 6, 5. You take many data randomly. 34, 90, 23, and now I want to terminate, so minus 1. And you see you are getting a sorted linked list. These numbers are sorted. You see 5 is smaller than 6, 6 is smaller than 12, and so on. So we have a program to reverse the elements of a linked list. Now I had said that I have to refine this program. You know, when we have the when before earlier I used only one for loop. In that you saw that in that case the largest element was at the end. This means that you do not need to disturb that end element. So for the next time you have to do less work, and for that corresponding to that we should modify here, and the modification will be count minus I plus 1, and writing this way will will make this program to run less and to give the same output, that is the sorted linked list. And I will modify this program here as well, here before the display, so that the output will look more meaningful, and for that I use here printf function, and here I type MSS, the sorted linked list elements are backslash n. So typing this thing will give us a beautiful output. So now since I have changed a little this program, so we should check the program once again whether this is giving us the sorted linked list or not. Here we go. And again this time you can take any number of data, whether 1000, 500 and so on. But here to save time, to keep the video short, I take few number of data, and here I take 23, 7, 56, 43, 86, 100, 89, and now I terminate -1 for that. And you see the data. See, 1, 2, 3, 4, 5, 6. There are 6 data, and this -1 is not included because you know this -1 is only to terminate the linked list. And here I press the key enter, and you see now, you see this is the output, and this is looking more meaningful because there is a language which says something. The sorted linked list elements are, obviously these are sorted 7, and 23 is greater than 7, 43 is greater than 23 and so on. And obviously there are 6 data, 1, 2, 3, 4, 5, 6. So this video may be long for some viewers, but I know for the new learner it is the best way to learn the C program. And you know, if you want to learn anything, it takes time. So, okay, so go ahead and try to understand all the steps. And once again, I show you the entire program, the entire code. Here I show you. Here is the first part of the program. Here is the second part of this program. And here is the last part of this program. Okay, bye for now.